Hemant. My project is about speech emotion detection. And I'm Lohit.
Myself, Rakshita.
Our project will predict the emotion of a speech, which will take an input as an audio file and process the audio file and predict the emotion of our audio file. We have used three algorithms. First one is CNN.
So first algorithm is CNN, where it takes the small part of the data, where it is called kernel, and then it is like there are convolution pooling. So first in convolution, it will recognize the part of the data, and then it is spatially reduced, like downsampled. In that process is called pooling, and then after several process, then it is flattened, like this will be in the form of 3D, and this is one dimensional vector, so that process is flattening, and then it is connected, like they are interconnected, and then at the softmax we'll get the output, like there will be score of like probabilities of the speech and the emotions which are there in the speech like audio.
Next algorithm is RNN, which is a type of ANN, where it works based on the sequential data such as time series and natural language test. Where the basic idea of this algorithm is, it will take a input, which uses feedback loop, where which take the output of a previous layer as an input to the next layer, which works. This is the basic idea how the RNN works, where there are the several applications using RNN such as speech emotion recognition, language translation, time series forecasting. For example, if you are searching something in the Chrome, it will suggest you the next sequence of data based on the current data. This is how RNN works. It's a type of artificial neural network. Let us know exactly how RNN works for our project. This exists the input audio file given to hidden layers, and it will process a feedback loop and it gives the output for this model. How this works is, first the hidden layer is considered to be a zero, everything would be zero. Then we give an input file at the particular timestamp t-1, and it will process and predict the output. This output will be given as a input to the next layer, and this is the complete process. It will process the same way for all the layers, all the hidden layers, and predict the output as it is a sequential data. With the drawbacks of RNN is vanishing gradient problem and exploding gradient problem. Vanishing gradient problem means when we are training a RNN model, then there is a loss function where the weight will be decremented. The weight will, if suppose we consider the weight is 29, it will be decremented to 28.99. There is a loss. So this will lead to a problem in the RNN.
So next is LSTM, long short-term memory. So the LSTM is used for vanishing and exploding gradients. So for this problem, the LSTM algorithm is used. So it is used in the field of deep learning, and it is the variety of RNN. So as he said, the loss can be identified in the LSTM, and it is capable of learning long-term dependencies and sequence prediction.
Among these three models, the LSTM is very efficient when compared to both the CNN and RNN, where RNN has a drawback such as gradient loss. The modules that we are using in our projects are Pandas is used for data manipulation and analysis, and we use a data structure called data frame for a sequential data storage, and the NumPy used for the mathematical and numerical operations. OS is used to interact with the operating system and allow us to perform tasks and to load our files and directories. And C1 is used for data visualization, which built upon a matplotlib. Matplotlib is also used to plot a graphs and data visualization. Libroza is commonly used for audio and music analysis. It offers tools like feature extraction, analysis, and manipulation that we are taking when we are in the hidden layer. We extract the features from audio based on the pitch and the frequency of audio, it will predict the emotion of audio.
So next is audio. It is the input for our project, and warnings. It helps the it gives the warning messages, and it also manages the unexpected behavior. And sklearn, it is a library which provides tools for machine learning and also for classification regression. Next is Keras, which is a high-level neural network, and it is built using neural network models. And sequential is used for linear stack analysis, and dense, which is used to connect the layers. And then LSTM, which is the long short-term memory, which is a type of RNN. And dropout is the regulation technique which is used to prevent overfitting.
The data flow diagram, this is what I explained before. This is the input speech audio that we give. It will process the deep learning algorithm will process the input speech and recognizes the emotion of a speech. As I said before, there are several layers such as LSTM activation function and dense layers in this, and it will process, these layers will process and extract these layers will extract the features and the pitch and the frequency of audio. Then it will process and recognizes the emotion of audio. This is the process. We give an input, it will pre-process the data and extract the feature using MFCC, and the efficient model that we are using is LSTM model, which is 100% accurate and predict the output.
So we'll see the model overview. There are 6 layers. So starting will be the input layer, and next is 2 LSTM, and next is activation and 2 dense layers. After this we'll be getting the output. So we can give the input in the input layer, and then it is given to the LSTM, and then it is
after processing all this layer, it will predict the emotion of audio. Thank you. I uploaded a file. I uploaded the audio file. It will predict the emotion of audio.